Hey, it's MathCat. Please graph this point to -3. Hit pause till you're done, and I'll hang out here till you're ready. Wow, nice graphing. So MathCat helped me trace out the path to find the point to -3. The one I circled in red, the first number is always going to be the x coordinate. That's the sideways motion. So MathCat went across to +2 to the right. And then the second number, which I circled in green, that -3, that will always be the y coordinate. Y coordinates describe the up and down location. So -3 is going to go down. So you can see MathCat tracing out down 3 steps to -3. And then there's the dot. Thanks, MathCat. Today we're going to look at graphing lines, which we've started studying before, but today we're going to work just from equations. We're going to look at 3 different types of equations and see how it is that we can make a graph just by identifying the key features from the equation without the need for any tables or anything else. So there are, first up, we get an example, and MathCat's going to help us graph this one. So we're going to graph the equation x equals 2. I know this one does have a table. We're going to do one last problem here with the table just so we can see something, and then we'll use this to look at how to graph just straight from the equation. So this equation says x equals 2, and that means that if we finish this table, x will always have to be 2. That's the only option because the equation tells us x has to be 2. So 2 here, 2 here, 2 here, 2 here, 2 here. All right, so then the y coordinates. So we get to use whatever we want for y coordinates. The equation has no indication about what you can or can't do for y, so use whatever you want. I like -3. Just saw that one a second ago. And then you can go ahead and beam some ideas straight into my mind here. We can do some other y coordinates, like +3. That's a good one. We can do 0 and 1. And how about -2? Okay, let's put these dots on the graph. So 2, -3 was the first one. That's where MathCat found our point in the do now. That's down here. To +3 is going to be up here. To 0, to 1, and to -2. So you can see all of these points line up this way. I'm going to go ahead and draw a line through all of those points. And since lines are infinite, they would extend as far as possible. If I had a larger piece of graph paper, I'm going to put arrows on the ends. So it's an infinite line. It will continue up forever. It will continue down forever. It actually kind of already did, goes off the bottom of the graph there. Okay, so let's see if we can find out what's going to happen with this equation. The 3 types of graphs that we're going to look at, let's start with the first one, x equals a number. So like the one we just saw, x equals 2, that's an example. But it could be x equals any number. Every single time that's going to create a vertical line. Vertical means it goes up and down, and the slope of a line that goes straight up and down is undefined. Slope is a measure of slantiness, and this one is so slanty, it's actually not slanty anymore. It goes straight up and down, and we call that undefined. Every single one of these graphs, x equals something, is going to look like this example drawing I have over here on the right. Wherever that x coordinate is, that's where the line will be located, but it's going to go straight up and down. Similarly, if we have y equals a number, it's going to give us a line with no slant at all. This one is going to go straight across horizontally, and we call that a zero slope. Zero because there's no slant to it at all. It doesn't slant up or down at all. It just goes straight across. And the y coordinate where this will be located is the same as whatever number shows up in the equation. Y equals whatever. So -3 is an example. Y equals -3. You'd go down to -3 and then draw a line straight across horizontally there. The last type of equation is going to have a bunch more parts to it. So it'll start with a y equals, but then it's going to have some number. We're going to call that the first number m. Y equals m times x, and then plus, could be minus, but plus b. So the m and the b represent, those would be actually numbers. They represent these two concepts. M, we remember, is always the the letter in algebra that is used for slope. So inside the blue circle, that m is going to be the slope, and the red circle around the b, that number is the y-intercept. So we've learned about intercepts in the past. There are x-intercepts and y-intercepts, both that exist on graphs, but this number in the equation is the y-intercept. And the y-intercept is what you're going to put onto the graph first. So you look at the equation, we just need to identify what are these two numbers, which one is which. The number at the end of the equation there is going to be just a number, no letters attached at all. It could be plus something, it could be minus some number, but inside the red circle, that's the y-intercept. Put a dot on the graph at that y-intercept, that'll be our starting point. Then we're going to use the slope to find the change. Just like we saw MathCat step out the path to find that point in the do now, we're going to do the exact same process, except using the slope to find the next point so that we can connect our dots and we'll have a slanty line. So my example could be y equals negative 3/4 x. That negative 3/4 is the slope. Negative 3/4 x plus 5, where the positive 5 is the y-intercept. And so that would look basically like this example that I have drawn over here to the right. Okay, y equals 2. So when we see it's got a y at the front, y equals, and then there's just a number that tells us right away this is one of those first two types of equations. So this is going to give us a horizontal line. So I'm going to find on the y-axis where it is 2, put a dot, keep track of that for myself, and then the line is going to go straight across from that point, sticking out in both directions, both to the left and to the right, at that same height of 2. Make it green so it matches, and then I'm going to give it arrowheads because it does continue forever. So every single point, any place on that line is always going to have that same y coordinate of 2. Next example, x equals 4. MathCat can help us find where 4 is on the x-axis, and then we're going to draw a vertical line right through MathCat. So every single point on this line is going to have an x-coordinate of 4. We'll go ahead and give it a color. We'll make it orange for MathCat. Arrows because it is infinitely long, both up and down. Any single points, if we wanted to place dots on there, any point on that line is going to have the same x coordinate. It will always be 4. All right, and here we have an equation that has all of the parts. It's got a y equals, it's got a blue number and then an x and then the red number at the end. So those blue and red numbers, those are the ones we need to pay attention to. Those are the details that will tell us how we need to draw this graph. So the red number, is at the end of the equation, but this is what we start from. That's the y-intercept. You can always identify the y-intercept because it does not have a letter on it. It's not got a y, it's not got an x touching it. It's going to be either a plus number or a minus some number. In this case, it's plus. So that's the y-intercept. MathCat will find that for us on the y-axis at positive 2. So I'm going to put a dot right here to keep track of that. And then the blue number is the slope. This one is a fraction. And when we deal with slope fractions, we know the top number is the rise. It's going to tell us what MathCat needs to do up or down. And the bottom number of the fraction is the run. That's going to tell MathCat how far he goes to the right. This particular slope is negative. Anytime you have a negative fraction for the rest of your math career, it will always be easiest if you take that minus sign and swing it up and attach it to the top number. So I'm going to scribble out the first minus and we'll put it on the top. So that's going to be part of the rise. It's going to have a rise of -1, a run of 4. So MathCat is going to go down 1 space, that's our rise, and then right 4. 1, 2, 3, 4. And that's going to be our next point. So we can just trace out MathCat steps. We went down 1 and to the right 4. So I don't want to leave that there because I want to keep our graph clean looking. So I'm going to connect those 2 points, the y-intercept and that next point we found by using the slope. And I'm going to make this graph green. We're going to put arrows at both ends. And then I wanted to draw my graph through those 2 dots. And so I lined it up on the 2 dots with my line drawing tool. But I don't actually want the line to stop at that dot. I want it to go as far as possible. We'll keep it on the screen, but as far as possible over here to the edge of the graph. Because it is infinite, I would like to have as much of it represented on my graph as possible. So I'm going to draw it as long as I can in both directions. All right, so here's just a second example, doing very similar things to what we did the last time. So the y-intercept is where we're going to start from. And in this equation, I've highlighted that in blue. So MathCat, go find 4 on the y-axis. Meow. Okay, MathCat's going to find 4 right there. I'm going to put a blue dot, keep track of that. And then our slope is the green number. So that is a fraction again, 2/3. The 2 is the rise, so it's going to go up 2 spaces, and the run always goes to the right 3 spaces. So MathCat is going to go up 1, 2. Oh no, 2 spaces. MathCat actually can't go 2 spaces up. He like disappears and goes back to where he started from. So I can get almost 2 spaces up, and then if we were just to imagine the MathCat could somehow stay up there, 1, 2, 3 spaces to the right, that's where that next dot needs to go. But obviously there's not room on my graph. So what am I going to do? Okay, well, if I could get MathCat to be in the right place right there and we're on the graph, this dotted line is where my line would go. But I can't get there. So I'm going to bring MathCat back to the y-intercept, and we're going to do the slope, but everything about the slope we're going to do in reverse. So instead of going up 2 spaces and then right 3 spaces, we're just going to do all of that backwards. So we're going to go down 2 spaces and left 3. So MathCat is going to go backwards, 2 steps down, and backwards, 1, 2, 3 steps to the right. And I'll use this dot I'll draw in green, since my slope is in green. And so now what you'll notice, hopefully, is if I connect this green dot with the blue dot I had originally, that lines up perfectly with that dotted line I just started before, if we could somehow get MathCat to fit above the graph up there. All right. So obviously MathCat is not something you're going to experience in your assignments, but the point I want to illustrate here is sometimes we have to get the next point in order to draw a graph and it doesn't fit. Okay, if that does happen, and it happens from time to time, then we can take the slope and go backwards, because between any 2 points anywhere on this line, we're always going to have the same slope. So whether it's between the blue dot I started at and what the next dot would be, where MathCat didn't have room to stand on the graph, that's the same slope of up 2 and right 3. Also between the green dot that I came back to, between the green dot and the blue dot, it's still the same slope, up 2 spaces and right 3 from green to blue. So there are an infinite number of possible points that we can use. The ones that we typically use are just the y-intercept and then the one that is next over to the right. However, if we need to, we can back up by doing the slope totally in reverse. And then we'll be able to fit our points on the graph. All right, next up, y equals -2/3 x. So I copied and pasted my highlighting and I just pasted it in here. And so let's identify these things. So in the green highlighting, -2/3, that is our slope. And then I just pasted in this blue highlight for the y-intercept. We remember that is where the y-intercept goes. Get those letters in there. Wow. Okay. But there's nothing there. It's missing. What am I going to do? I don't know where to start my graph. There's no y-intercept. Except it's not actually missing. It has definitely not been written there, but if we think about just from a very like superficial level, like what is written inside that blue highlighted section, nothing, right? Well, that's actually what's there. Nothing. Zero. Zero means nothing. That is the y-intercept. So if the y-intercept is not written down, it's really just telling you that the y-intercept is zero. And typically in math, we don't write zeros because like they mean nothing. So there's our y-intercept at zero. We can send MathCat over here to the y-intercept. Come on, MathCat, don't get stuck. And from this y-intercept, to find the next point, we just send MathCat after the slope -2/3. So I'm going to take the negative sign, slide that up onto the top. So my rise is going to be -2. The run will be 3. So MathCat is going to go down 2 spaces, and 1, 2, 3 spaces to the right. MathCat's being stubborn. All right, and then slope. We're our next point in green, since the slope was green, and now we can draw our line from the blue dot to green one. And again, we're going to draw this line as long as we possibly can. I'll extend it back here to the left so that we have as long a line as possible. We could even go over the words I wrote before. And then we'll go ahead and stick some arrowheads. And we'll make this in purple. All right, last one. Y equals x plus 2. And again, I just copied and pasted my highlighting from before. So I can see this green highlight is where the slope should be, except it seems like it's missing. And over here in the blue, there's my y-intercept. Okay, well, I know what the y-intercept is. It's 2, so I can go ahead and put that onto my graph. And we can send MathCat over here to keep guard of our y-intercept while we figure out what to do with the rest of this equation. So where the slope should be, there's just some green highlighting that I copied and pasted there, and there's no number. So the previous example we saw, if there was nothing there for the y-intercept, that meant 0. And this one, it's not really true that there's nothing there because the x is still present. And if there's an x there, it means there's one x. But we don't ever write 1x. We just say x, and it means that there is one. If there's a different amount of x's, then there'd be a number there specifying how many x's there are. But if I happen to have a decorative pumpkin, I don't need to tell you that I have one decorative pumpkin. I just say I have a decorative pumpkin, and that means I have one. Same thing happens with x's. So my slope is 1. Anytime we have a whole number for a slope, we can turn that into a fraction, so we get rise and run. Just put the denominator of 1. So if the slope number is invisible, that means 1. Okay, that only is true when there is not a number given. Anytime you have a whole number, whether it's 1 or 5 or -8 or anything, you can turn it into a fraction by making the denominator 1. So it's not related. It's not 1 because the other one was 1. It's just denominator will always be 1. So MathCat is going to find our next point by doing a rise of 1 and a run of 1. It's going to go up 1, and we're going to go right 1, and then our green dot is going to go right here. And then we're going to draw our line as long as possible from one side of the graph to the other, filling as much of the graph as we possibly can. Arrows at both ends. And I think this time, let's do orange for MathCat, SmashCat's favorite color. All right,